Welcome to Tech Teach.
So next we will see the flow and error control. So starting, we will be basically considering the flow control. Most important responsibilities of the data link layer is the flow control and the error control. So these are the two main responsibilities of the data link layer basically. So here collectively, these functions are known as data link control. So by combining the flow control and error control are considered to be data link. One by one, we will be looking at what is flow control or what is error control. So here the flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for acknowledgement. So in flow control, it is basically about what amount of data we need to send that is given by a set of procedures. So flow control gives set of procedures that will be basically concerning about what amount of data we need to send till there is an acknowledgement received from the receiver data. What amount of data sender can send before waiting for the acknowledgement. So before an acknowledgement is received from the receiver, what amount of data a sender can send, that is basically given by a set of procedures. So this set of procedures will be called the flow control basically. Next is the error control. So in error control, the data link layer is based on automatic repeat requests. So error control is basically done by automatic repeat request. So this is called ARQ. So we will be looking this part later on this into the slides. So if there is an automatic repeat request, so whenever there is an error occurring while sending a data or while receiving an acknowledgement, so automatic repeat request is basically activated and it retransmits the data. It will be retransmitting the data so that there should not be any error. So this is basically the error control. So that part will also be considered or covered into the next few slides also. So we will be looking at different protocols that basically governs the flow control and the error control. So what are the different set of rules or set of techniques that will be controlling the flow and controlling the error. Now let us see how the data link layer can combine framing, flow control and error control to achieve the delivery of data from one node to another node. That is, here the protocols will be used. So the protocols are normally implemented in software. So these protocols will be implemented in software by using one of the common programming language. So any programming language can be used to implement these protocols or set of rules that will be represented by a software. So for writing these protocols, some language can be used. So instead of focusing on a particular language, here a pseudo code will be used to identify like what is the procedure. So a pseudo code will be used instead of a particular programming language to identify like what is the procedure. So that we will be considering one by one. So there are different protocols are there, flow and error control protocols. So these protocols are basically divided into two different types. One is for noiseless channel. Another one is for noisy channel. So for noiseless channel means channel in the sense the transmission medium. So if there is a channel that is a noiseless, that means it is like an ideal channel. And it is noisy channel in the sense channel can have the noise capabilities, so that will be the noisy channel. So these are the practical channels. So because the practical channels are the one that can have the noise effect, but in ideal it cannot be affected by noise. So that's why it is called like noiseless channel. So we will be starting with the noiseless channel and then we will be going with the noisy channel. So in noiseless channel, we are having two different protocols. So one is called the simplest protocol. Another one is called stop and wait protocol. So this is for sending a frame. These are the two protocols that will be for sending the frames from sender to receiver through a noiseless channel. So if it is a noiseless channel means there is no possibility of error. Okay. and no flow control is basically here required basically, or like no flow control and no error control is basically required because it is an ideal channel. Okay, so once you have sent, it will be reaching to the receiver side for sure. That is a noiseless channel. Next one is noisy channel. Here, three different protocols are basically defined. So one is stop and wait ARQ. So ARQ is automatic repeat request. ARQ that we have just seen. So that is basically ARQ means it is automatic repeat request. These were basically used for error control. So error can only be possible in noisy channel. So if there is a noisy channel, then only ARQ will be used. Means automatic repeat request will be used because there is a possibility of error. Another one is like go back and ARQ. Next one is selective repeat ARQ. So these are the different protocols that will be utilized for noisy channel. So we'll be starting with the first one, that is the simplest protocol that will be used for noiseless channels. So in noiseless channels, what is a noiseless channel we will be considering? So let us first assume we have an ideal channel. So ideal channel in the sense that is the noiseless channel in which no frame are lost. Frames cannot be lost into an ideal channel, and also it cannot be duplicated. Frames cannot be duplicated, and also or corrupted in the sense uh, there should not be any error into the ideal channel. If we are sending a packet, that packet will be reaching to the receiver because there is no error in between. Error due to the packet loss or the frame loss or duplication or because of corruption into the frames. So it is not there into the noiseless or ideal channels here. So we will see here two different protocols, simple and stop and wait uh, protocol here. So the first one is the simple protocol. What is the basic idea about the simple protocol? So it is considered as like unidirectional. Unidirectional means if sender is there, the sender will only be sending, the receiver will only be receiving. So this is unidirectional from sender to receiver side. Okay. So what is the basic procedure here is sender wants to send a packet. Okay. Then a packet or the data will be provided from the network layer to the data link layer. So data link layer will be getting a data from the network layer. Then this data link layer will be doing the framing here. After framing, it will send the packet. So once the data is received, framing, then send. Data received, framing, and send. It will just send. After sending, where this packet is going, it is not the worry of the data link layer or the sender side. So once the data is framed, it will be sent. It will be sent. Whether the receiver is able to receive or not, that is not their case because it is first of all noiseless channel. So it is for sure like whatever the send packets are there, that will be reaching to the receiver. So that's why here after one next packet is sent, then next frame is sent. Basically, this here the data is in the form of frames. So okay, so data frames are being keep on sending once the frame is ready, and at the receiver side, the frames will be received by the physical layer. This will be informing to the data link layer. Here the frames are received, then it will be destocked and then delivered to the network layer. So this is the basic idea of simplest protocol. Okay, so in simplest protocol, in terms of this is basically the structural analysis, like structural analysis, and this is the algorithmic analysis. So how the algorithm should be implemented. So here it is saying like there will be an event. Event means a trigger point. So when this frame sending should be activated at the sender side, that there will be an event. That event will be a request from the network layer. So network layer will be requesting data link layer to send a frame, okay, or send a data basically. So that data will be available into the network layer. So when a request is given to the data link layer will be asking for data from the network layer. So get data, then framing, then send. The next request will be coming from the network layer, then same thing will be performed by the data link layer. So this will be repeated forever. So this algorithm will be here, algorithm for the sender side will be getting the data, framing and sending, getting the data, framing and sending likewise. At the receiver side, when this receiver will be activated, so receiver will be activated by a trigger point that is called the event. So this event will be notification from the physical layer. So whenever the first frame will be reaching here, it will be reaching through the physical layer. So physical layer will be notifying this data link layer. So notification will be done by the physical layer to the data link layer to perform some algorithms or some procedures. So that procedures will be like receiving the frame, then destuffing it, then sending to the network layer. So this is the work of data link layer at the receiver side. So the same thing is being given here. So at the center side, there is a pseudo code is given or algorithm is given. So center side, the algorithm for simplest protocol. So for simplest protocol, what will the algorithm for the center side? So it will be forever true. So it is repeat forever means it is true forever. So there is a while. So inside a while, there will be some set of codes. So that first code is like wait for the event. So sender should be waiting for an event. So if there is an event, event means notification or the request from the network layer. So if there is a wait for the event, if the event is request to send, if the request to send event is activated, then the data link layer will be getting the data, then making a frame, then sending the frame. This will be done. If there is no event from the network layer, it will be keep on waiting. If there is an event, it will be doing this. So this is how the algorithm for the sender side is implemented for simple protocol. Next is at the receiver side, what is the algorithm for simple protocol? So at the receiver side again, it will be repeat forever. So whatever is the process, it will be repeated forever. Okay, so this process will be repeated forever, and there is a while true. So whenever there is a true, means it is always true. So inside that again, it will be waiting for an event. Event is basically here the what is the event? Event is notification from the physical layer. So if the event from the physical layer is there, means arrival notification is there, then what it will be doing is it will be receiving the frame, extracting the data, and then delivering the data to the network layer. So this is the basic idea of the simple protocol that is we have seen the previous. So this is basic about the simple protocol. Next, yes, here is an example is given like how the communication takes place into the simple protocol. So there is a flow diagram basically. So this flow diagram is going to explain the working of the simple protocol. So there is a sender. So first of all, there is a sender. So sender will be sending a data. So this will be sending the data only when the network layer have given a request. So request from the network layer, then the data link layer will be framing the data. After framing, it will be sending the frame. Okay. So if the next request is coming from the network layer, it will be framing, getting the data, framing the data, and then send. Then another request. If another request is given by the network layer, the data link layer will be getting the data from the network layer, then framing it, then send it. So this is done at the sender side. Whether this frame is received by receiver or not, that is not their problem. This will be just getting a request, sending the frame, getting a request from network layer, sending the frame. Likewise, at the receiver side, whenever there is a frame arrived at the physical layer will be notifying the arrival notice or going to give a notification for arrival. So based on this arrival, the receiver will be destuffing it and sending to the network layer. Likewise, it will be done. So this is the basic idea into the simple protocol. So whenever there is a request, frame is sent. Whenever there is a request, frame is sent. It will not be worrying about anything, acknowledgement and all. So this is the basic idea of flow control for simplest protocol. The next is the wait and stop and wait protocol. So the second part, the second one is stop and wait protocol. So in a stop and wait protocol, what is the procedure? We will just see. This is like structure design. So how it will be done is at the center side. So network will be first of all, it will be going to give a request to the data link layer. So the first event will be like first event. the request from the network layer. So network layer wants to send packet, then it will be requesting the data link layer. So once the request is reaching to the data link layer will be getting the data from the network layer. After getting the data, it will be doing the framing. Then it will be sending the frame. So here, whenever the first request is there, with respect to first request, it will be sending the first frame. After sending the first frame, it will be received by the physical layer. It will be going to give the notification to the data link layer. It will be receiving the frame, then destuffing it, then deliver to the network layer. After delivering, this data link layer will be sending another frame. That frame will be called the acknowledgement frame. So here, after receiving the data and delivering to the network layer, the data link layer will be sending acknowledgement to the sender. Okay, so at that time, sender will keep on waiting till the acknowledgement is received from the receiver. So if acknowledgement is received, then only the sender will be accepting the next request of the network layer. Hence, at a time, one frame will be sent. So some of the properties here is, like it is going to have, first of all, one frame at a time that will be sent. It will be waiting for receiver acknowledgement. It will be waiting for receiver acknowledgement. Then only once it has received the acknowledgement, then only it will be sending the next frame. So this is the basic idea about stop and wait. So how it is done in event level. So once there is a event, first event is a request from the network layer. Then it will be framing and sending the packet. Once the packet is sent, it will be going to the physical layer. So at the receiver side, there will be an event that there will be a notification at the physical layer. It will be providing to the data link layer. It will be doing some process. So that process will be accepting the frame, then deframing, destuffing, and then sending to the receiver, the network layer basically. So after sending to the receiver side, it will be sending an acknowledgement. So that acknowledgement, will be received to the physical layer. So this physical layer will be providing a notification. That will be the second event for here. This is only the first event at the receiver side. At the sender side, two events will be taking place. So notification from the physical layer. Then it will be going to give this notification to the data link layer. Then data link layer will be ready to accept the next request from the network layer. So this is the basic idea about the stop and wait protocol. So here there is an algorithm at the sender side for stop and wait protocol. So how the algorithm is going to work is, the first is here, like it is true for each time, true for every time. So repeat forever. That meaning is, then there is a variable can send is equals to true. If the can send is true, then it will be waiting for the event. If the event takes place and can send is high, then if both are high, then the data link layer will be getting the data, making the frame, sending the frame. After sending the frame, it will be making can send to false because it has just sent the frame. So after sending the frame, it can't send the frame now. It will be again able to send the frame only when the acknowledgement is received. So the next is waiting for the event. If the event is like arrival of the notification, this is the second event. So this was the first event. So arrival of the notification of acknowledgement basically. If acknowledgement is received, then it will be receiving the frame, acknowledgement frame, it will be received. Then it will be activating the can send to true. So till the acknowledgement is not received, the can send will be false. If the can send is true, then it will be able to accept the request for this event. And this is how the stop and wait protocol basically works at the sender side. At the receiver side, it is similar to the normal, the simple protocol case. The only difference is here it will be sending a frame for acknowledgement. This is the only difference. Otherwise, it is similar to the previous one. So it will be at the end of this, after the receiving and sending to the network layer, it will be sending a frame, that is acknowledgement frame, to the sender side. So this is the basic difference at the receiver side of stop and wait protocol. So here flow diagram is given. So what is the flow diagram is here is like if there is a request from the network layer, request, this is from network layer. If there is a request, the data link layer will be getting the data, then framing it, then send the frame. After sending the frame, there will be arrival notification at the physical layer that will be activating the data link layer. Then it will be accepting the frame, sending the frame to the network layer, and then sending a new frame, that is acknowledgement frame, to the sender side. If the acknowledgement is arrived here, then the new request will be done by the network layer. If the new request is given by the network layer, then the data link layer will be getting the data, then framing it and then sending it likewise. Then next acknowledgement is received. So here it will, after sending, it will be stop and keep on waiting. So after sending, so first of all, here it is sent. Then after sending, here up to here it is waiting. Okay. So if it is waiting, then here it is stop. Like if there is a request, then it will again send and then stop. Here this is like basically waiting. When there is arrival, then it will be able to send based on the request. So likewise, so it is stop and wait protocol. Next we will see some of the limitations to this protocol. First limitation here is problem due to lost frame. Say like suppose there is a sender, there is a receiver. If sender get a request, it sends the frame. Okay, but this frame got lost. If the frame got lost, receiver will not be able to receive the frame. If receiver has not received the frame, it will not be sending the acknowledgement also. That means if the acknowledgement is not sent from the receiver side, the sender will keep on waiting to infinite time till there is an acknowledgement, then only the next frame will be sent. If there is no acknowledgement received from the receiver, the sender will keep on waiting for infinite amount of time. So that is the first problem. Okay, so problem due to lost frame. The second problem is problem due to lost acknowledgement. So second one is this is sender and receiver. So sender has sent the frame, it has received by the receiver, but once acknowledgement is sent by the receiver, it got lost in between. It has not received to the sender side. So if acknowledgement is not received to the sender side, again here the sender will keep on waiting. Okay, so that is the second problem. The third one is problem due to delayed acknowledgement. Delayed acknowledgement means acknowledgement would have been received prior to that. So this is sender, this is receiver. Packet is sent, it is received, and the receiver has sent the acknowledgement, but it is received very late. Okay, so if it is received very late, then at that time the sender might be thinking like this is acknowledgement for what frame, which data frame this acknowledgement is about. So that is also the problem. These are the different problems associated with stop and wait protocol. That's why there is a next protocols, different next protocols are there.